So today we discuss conservation of energy. So work energy power last topic here. Okay. So conservation of energy. Okay. So what is conservation of energy? Okay. What does the meaning of conservation? So conservation means so energy is conserved means energy is conserved. So energy means conserved means the total energy is fixed. Total energy is fixed. Some fixed value, like suppose that take an example, consider 10 joule, that is a fixed energy. Okay. So according to that conservation energy principle, the principle say that so energy neither be created nor destroyed. So that states that conservation of energy principle so, of conservation of energy states that energy neither be created. So energy neither created nor destroyed. So energy neither be created nor destroyed. It transforms one form to another. It transforms one form to another. That's the conservation of energy principle. Okay. So that's the elaboration states that if there is a taken an example, that's an event. If this box is an event, before that event, the total energy suppose that is equal to 10 joule. And after that event, we also get the total energy that is also equal to 10 joule. Okay. So total energy before event and total energy after event, but both are in same magnitude source. Okay. The 10 joule and 10 joule. And we know the energy is a scalar quantity. Energy is a scalar quantity. The scalar quantity. Okay. Now, so, and in between that event, okay, in suppose consider that in between an event, if starting event, that is a ending event, and in between event, that is a choose any time or any point. Here also the total energy constant. Total energy also the 10 joule. Now, what is total energy? The total energy means basic. There is a kinetic energy plus potential energy. Okay, the total energy means if sometime at kinetic energy is greater than potential energy, or sometimes potential energy also greater than kinetic energy, or sometimes they are equal. Okay, then doesn't matter. But if I added these two energy, we get a total energy is fixed value. Okay, so that is a total energy is constant. Yeah, fixed value. Okay, that is theoretical verification of kinetic energy plus potential energy is constant. Now need to put that. Go to the next page. Okay, so we try to solve this. We're going to this next page. Suppose there is a building and try to prove of that principle of conservation energy. That is a building. As the height of the building is h. That is a h. Okay. At top of the building, a ball or an object placed here. And if someone push that ball, then ball goes down because due to the gravity. Okay, at the top of the point, okay, ball is at rest. Ball is at object is at rest. So we know that kinetic energy that is equal to half mv square, and potential energy also equal to mgh. But at the top of the building, okay, so ball is at rest means the velocity equal to 0. So kinetic energy is 0. So mass into 0, that is we get is 0 joule. But at that height, h is maximum. So that is equal to we get mgh. So total energy that is equal to kinetic energy 0 plus mgh, 0 plus mgh, that is joule, that is we get as mgh joule, the total energy at the top of the building at that point. A point is a point here, the total energy is mgh. Okay, now at a not a midpoint, at any point in that height, at any point, okay, at any point, this point B, as point is B point. So now consider that being x, okay, from top to that point the distance is x, and then bottom to that point, that is h minus x. Very simple. Okay, now if someone push that ball, the object, or the object goes down, and if object goes down due to gravity, so velocity increases. So body or object are accelerated. If body or object are accelerated, so velocity increases. If velocity increases, so kinetic energy also increases. Because there's some velocity. Mass is fixed, constant, but velocity increases. If velocity increases, the height is decreases. See that the building height is decreases. If height is decreases, so potential energy mgh also decreases, kinetic energy increases, and potential energy decreases. Okay. Suppose at that point we consider that if u initial velocity equal to 0, and that is a final velocity at v at any value, at any value. Now we try to calculate that value. So we know the motion basic equations. Okay. Now we calculate the v. So that velocity, if object from that point to that point, u is 0. So from motion third equation, we know that v square equal to u square plus 2g. That is the displaced object displaced from that point to that point, that is x. And that is equal to v square equal to u0, that is 2gx. So kinetic energy that is equal to half m v square, that is equal to 2gx. 2 to cancel, that is mgx. That's the kinetic energy at point B. At point B. Now what is the potential energy at point B? Now potential energy at point B. So what is potential energy? At that point, that is the loss of potential energy from top to bottom, okay, because there is a high loss of height. But what is potential? Potential energy calculated from height. That height is calculated from ground to at that point. Ground to at that point. So that height is h minus x. That is equal to mg h minus x. So that is equal to mgh minus mgx. Okay. So total energy being we get kinetic energy plus potential energy, kinetic energy that is equal to mgx, and also potential energy we get mgh minus mgx. We cancel these two, get total energy also the mgh at point B. We get a potential total energy is mgh, and at top of the point A we also get total energy that is also equal to mgh. Now at the bottom of that point, at bottom point is like point C. So point C, at point C, the h is equal to 0. So potential is very simple, mg times 0, that is 0 joule. But kinetic energy, so if we consider ball or object goes that point to ground, that is U equal to 0. Calculate V at some value. What is the V? From motion third basic equation, V square equal to U square plus 2G. And what is the G? Why consider the G? The G's body goes downward. Okay, if body goes downward means action due to gravity. So A change to G. Okay, when you know that the A to AS or X, the X is the displacement and acceleration. Bodies get accelerated. Okay, because body from velocity 0, if the acceleration why due to the gravity, there is accelerated. So V here some V value that is calculated. So 2G and body or object displaced that height. Okay, from top to that point, that is a H. That is a H. And U also 0. That is equal to 2gh. So half m v square we get 2gh, 2 to cancel, that is also equal to mgh, and total energy we get mgh, kinetic energy plus potential energy, that is potential energy 0 joule. So we get mgh. So here the 3 points we conclude that at point A, point B and point C, at 3 points we get total energy also mgh at top. At point B we also get total energy is mgh. At point C we also get total energy mgh. So that's the verified the principle of conservation of energy, because the total energy is fixed value, is conserved. At that point total energy is conserved or given a fixed value. Suppose the 10 joule or 20 joule. Its kinetic energy, potential energy may be differ, but total energy are same. Okay. Now, if I draw a graph, that situation, draw a graph like that. If I draw a graph like that, there is a displacement from ground to height, suppose h. Some height h. At ground, at that point, origin point h is 0, and that is the y-axis represent energy, the total energy, and here the total energy is constant, means a fixed value. Suppose that is a total energy constant, T E some 100 joule. That is a fixed value. Yeah, fixed. If this color represent that potential energy, at ground potential energy is 0, but kinetic energy is maximum. So if I draw the potential energy at that point, potential energy, if height is increases left to right, so potential energy also increases. So this line represent potential energy. Now, if I draw kinetic energy, at ground kinetic energy is maximum. Okay, if kinetic energy is maximum, if kinetic energy here brings maximum at the bottom, because that the v square equal to 2gh, that maximum. So here we get that maximum point, and at height, maximum height, the velocity being 0, so kinetic energy also decreases. So black line represent kinetic energy at any value, like suppose consider that height, suppose that h is equal to some, to consider 5 meter at any value. Okay, at any value here, what is the potential energy? Suppose potential energy here, if I potential energy, and what is the kinetic energy at that height a, that is a potential energy. Okay, this height is the potential energy. So what is kinetic energy? the kinetic energy at that height h equal to 5 meter, we get at that point the kinetic energy is, so kinetic energy, suppose this energy at ground. Now if I added that the kinetic energy at height that point h suppose 5, if potential energy at that height p equal to mm, mm, p equal to some that at height 5. If I added these two energy, we get total energy. So total energy is at height h equal to 5 meter, that is ke 5 meter plus pe h 5 meter, that is the total energy constant, a fixed value. Suppose that is we get 100 joule. Okay, that graph represents that function. Okay, the total energy is a fixed value. Okay, now clear. Okay, so here the application of principle of conservation of energy. The application is like a simple pendulum. In our class 10 syllabus we can just discuss only simple pendulum application of that equation, study a simple pendulum. Very easy. So draw a diagram at fixed point. Here is a bob from left. If I draw at that point, here the bob, and that is here. Okay, there are three position: extreme most right, that extreme most left, and that bottom point. This line is not look like a straight line. So if I draw a perfectly straight line, it look like this. Okay. So here we get that is some maximum height h, that is also a h, both are same. So at that height, bob goes that direction, then stop, then back. Goes that, then back. So that is velocity 0 at that point. So velocity 0 means potential energy equal to mgh, that is a maximum, and that is kinetic energy 0 because the velocity is 0. At bottom at that point here, the velocity is maximum. So kinetic energy, that is a maximum. Okay, half mv square. And but if I potential energy, kinetic energy is maximum, so potential energy being 0. If potential energy is 0, the total energy also constant. Okay, here the total energy also constant, fixed value. But similarly, similar to the right side, extreme right, so potential energy at that point P, that is equal to mgh, kinetic energy 0. Why? Velocity being 0. So if same case here, if velocity goes there, the bob goes this direction, velocity goes this, then stop, then to and fro motion. Okay, clear. So but here just the total energy always fixed. If the potential energy is minimum or kinetic energy maximum, or they are same at that position in midway at that point, kinetic energy, that is also equal to potential energy. Similar like at that point, kinetic energy also equal to potential energy. Okay, that is simple Bob convention. What is if I calculate that? That is half mv square. We similarly like that get also, that is also equal to mg. Similar like if you calculate here. Okay, that is also the get kinetic energy, that is also equal to mgh. Okay, similar type of calculation here. So I skip that calculation. So where the main important part here, that total energy is a fixed, okay, base means conserved, some value of fixed value, okay. So if some part of form of energy, potential to kinetic, kinetic to potential, but total energy get a fixed value, means a principle of conservation of energy, okay, very easy. So today I can end the class here. Next class we will just solve basic numerical, okay, part C. If you any doubt, put in comment section. I will try to give the answer. Thank you.